All right, we'll have to figure it out. If there's a problem with the light, we'll figure it out. All righty, so welcome. We're gonna do today this pattern. We're gonna work around with the idea of circuits. It's a very nice circuit. It's gonna be related to the basket weave that we've done before. And if you recall, the basket weave was done with thirds, and it's gonna be very interesting to see how this is done in thirds. Now, we need for this one an equilateral triangle grid. Now, we're very lucky to know how to do those. And this time, we're not going to do it on a triangle. Although that I find certain advantage to using a triangle, I think also it's worth every now and again using a rectangle, just a matter of expansion, especially now that we know that what we're doing is a tessellation and not any structurally dependent object or design. Rather, it's just something which happens to be on an equilateral triangle grid. So we're going to establish that on a rectangle today. We're not going to do that on the equilateral triangle, but there will be an equilateral triangle within our rectangle. Now, we have choices. So whether you decide to go for a bigger expansion, if you have an A4 paper, I believe that you might be able to get one more jump into it if you want to get a bigger sort of rectangle. So of course, you know, old school, we're bringing this corner to the center fold, making sure that it bounces from the other corner, hits there. Once I have this fold established, what I'd like to do is I turn my paper over, like so. You can see the shadow on the back, a little bit of that triangle. I'm going to take the remainder of the fold and put that remainder onto our folded edge here. And that pretty much solves it. I mean, right there, we've done already the equilateral triangle. Pretty fast, pretty slick. So this engagement with the equilateral triangle should allow us for a quick and easy sort of expansion of our grid. Okay, so we have this right now. Now, if you have an A4 paper, I believe that you might be able to get another jump into here, which might satisfy something. So, you know, check this line. For instance, for me, this line is not reaching my edge. If it was, maybe I could, you know, use that as a further expansion. But for me, I'm simply going to cut there. I'm simply going to cut where the top of the triangle exists almost. So I'm going to leave that folded in on that point. And so I'm making sure that the line is perpendicular. By that, I mean that, you know, up in here, this line is falling on itself. And so is this one. I can appreciate how this line is continuing. So once I establish that, I can unfold. And it's going to be a simple one cut. I'm not going to cut the triangle. I am going to cut this edge right here. So I'm going to have this rectangle this time. Now, what I was saying about the A4 was that perhaps you might get another bounce. You might get another line. I'm not sure actually. I'm just guessing. But you know, check if you do. If you want to have a bigger rectangle, bigger expansion on your pattern, might be worth it because after all, we're only going to work with circuitry. And there we are. And so very nice, we have this equilateral triangle rectangle. This is say √3 to 2, right? If this is 2, then over here we have √3. Or this could be 1, and this could be √3 over 2. So we're gonna try to keep our grid exclusive to the equilateral triangle. So only lines that are going to be only these 3 lines: 1 line, 2 line, 3 line. We're not going to get 6-fold. We're only going to get 3-fold. So only these 3 sets of lines: 1, 2, 3. So next line. So if we could establish that, you know, we need this same line, but up in here at this point, we simply take this point right here and we match that there like so. You can see that I'm taking my corner and bringing it up in here. Let me just, I'm using Bluetooth earphones and they run out. I didn't charge them naturally, so I'm sort of juggling. with them. There we go. So taking the corner and putting it on that intersection, you can see how that also, takes me to my corner over here. Very nice. Same thing for the other one. So just as an exercise, you begin to wonder, all right, so which line is this line parallel to? So which line is this fold parallel to? You can see there, it's to this one. So it's these two lines which are parallel. And it's these two lines which are parallel. And now we need another parallel here. So we can simply, take advantage of this fold in the middle and simply go dividing in half, at least this way. So let me just get this thing set up because, earphones completely out of battery. So that's dead, so I'm gonna have to use my earphones. They go into my ear, they go into the microphone. So thank goodness for this. So up. And there we go. Yes, all right. The advantage of this is that I can sort of monitor myself also. Okay, so fold this in half. And we fold the other one in half as well. So we're pretty much just expanding our grid. In order for this to be worth it, we need at least a 16 by 60. So as you can see, we're gonna need a line that goes through this point and this point. This goes right between these two lines. Now, right now, it doesn't really matter which line is whether a mountain or a valley. It doesn't really matter. What matters is that the line is correct. And by correct, I mean that it goes through our parameters, that it completes our necessities. And so right now, because we wanted to go in the middle, what we could do, well, I changed it, I didn't have to change it, but we can take them both as mountains and do the double mountain trick, where the double mountain trick involves sort of identifying which two mountains you would like a valley to go between, and then bringing them together. So I can take these two lines, which are parallel, like so, as mountains, and then I can bring them together with this valley in between. So I just take my thumb in there in the middle, and so I can now manipulate the paper like so. And when I do that, I make sure that the fold lines up with the other mountain. And so these line up, make sure that that lines up as well. Boom, boom. And I fold straight, go all the way. Now, I did the double mountain technique because it's more simple to me. But if you do it, and you can see that it goes through my points here, bum, bum, I can fold it, and then I can begin to appreciate which relationships could I have taken advantage of. So instead of doing the double mountain trick, I can sort of do a reverse engineering thing where I can do a fold and then begin to analyze what is happening. What could I have done differently in order to avoid that technique, or what other sort of relationship could I have taken advantage of? So I can see that when I fold this, that for instance is matching to there, and this line is falling on itself. Same thing should be happening on the other side because it's, it has mirror symmetry like that. This line is also matching to my edge right there. I can see it perfectly going in, hits the edge, and then coming out. So this point hits the edge. This point, this line is falling on itself, and this one is coming in also on itself, but also hitting on that point. So I'm going to try and do the next one by those relationships. So this one's going to match to there. This one's going to match to here. Match, 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 and match. So again, another way of doing exactly the same thing. Whatever works for you, that's what you got to do. Now here, take the corner, put it on that point. Take this corner as well, take it on that point. And you can see how there's these bounces, or at least that's how you can appreciate them. I like to think of these arrangement as though they were rooms, right? So it's like these are walls, and then we get like a little light beam coming in, hits the edge of our room, and then bounces out. Hits the edge of our room, bounces out. And so we have this little weave that we're sort of intertwining and webbing. Take the other corner, put it on this point right here. Same thing for this one. So again, we're just establishing the grid. So if you're getting the idea, you can sort of go forward. We need a bigger grid in order to make this more interesting or be worth it. So again, another division in half. So what I'm doing here is I can simply take this line and just bring it down onto the edge where I want to be at. In this case, it's right there on this edge. Now again, I could unfold it completely and see what's matching in order to approach it from a different way. So simply, just lines falling on themselves because it's all being equally divided. So it's pretty simple, but I like to use this double mountain, or at least a single mountain, and then sort of like this erosion idea. You take the top of mountain and it sort of comes down to the bottom. That creates a valley right there. Also, an advantage to this way of looking at it is that once you have this fold, you can simply take what's falling and then you fold it to the other side. And what that does is that it unlocks this fold as a channel, if you will, because we have a valley, mountain, valley. So that allows this to sort of crunch. So we could also interpret it in those through that lens. Now, a lot of these designs have to do with your capacity to imagine solutions. And a solution requires you to be engaged with the material. You need to sort of be aware of the limitations that the pattern is presenting upon you. So you might have an idea, but that idea might not be something viable. But there will be some sort of workaround for your idea to come forth. How complicated that is, we don't know. It really depends on the idea. Some have easier solutions than others, and some will require computer assistance. But I think that's the rare case. I think that we should use the computer for just fact checking, just making sure that we are correct in our assumptions, or just as a way to sort of circumvent what could be a lot of work. So because life is finite, we have to take advantage of those tools, because as much as there might be honor and glory or whatever, there actually isn't. But if there was honor and glory and just doing everything on your own with your own hands, then more power to you. But because life is result based, and you could just achieve much more if you actually just use a computer for a lot of these things, you could use it as a tool, and there's no shame in it. After all, if that makes your pattern more interesting, then why not, right? So that's something that Ron Resch has been thinking about. I mean, well, he's dead now, but Ron Resch was this origami artist. He has several designs to his name. Actually, now that I'm thinking about it, I forgot to upload the thesis that I've been reading. I found this thesis online regarding, okay, so I have my sort of like the cross folds in, right? The ones that are going sort of diagonally to this grid. And now I need the ones that are going parallel or perpendicular to the edges, right? It's going to be perpendicular to these and parallel to these. So it goes like this. You can clearly see in your grid which lines are going to be requiring this fold. It's going to be pretty obvious, I believe, just the way that everything just comes down together. Now, I might be sort of going maybe a little bit too fast. I lose track of sort of how fast I am, but I think that you might be catching up to me, right? You might be on the same part, right? So yeah, if you don't know about Ron Resch, I'd recommend you watch this documentary on him called the Paper and Stick film. It's from the 80s, and yeah, it's about how he was using paper folds to design these very beautiful sculptures and geometrical objects. And yeah, he was very much fascinated by it. I think he used it as a tool. I think that folding came secondary to him. I think he maybe always folded, I believe, or didn't pick it up until later, something like that. And then it just really served his purposes of sort of spatial exploration. And yeah, he just became sort of internationally well known. I mean, he just became renowned. And he was just very passionate about the folds, and he was always bringing new mediums to the folds. And this sort of comes together with Robert Lang. In a way, Robert Lang is a very important character in all this, and that he holds many of the origami mathematical knowledge. I mean, I think he just has the sight for it. I think he can understand it. So his book, Origami Design Secrets, is one that I think is very useful. I've personally haven't gone through it completely, but I think that his work is really going to help many people who are, well versed in origami, and those who aren't yet. So we're in this grid now, and I'm gonna keep one more step in because we wanted to make it interesting. Otherwise, it's not going to be as fun. As much as this motif is already accessible to us here, it will not be, that exciting. So I am repeating the process of sort of selecting a fold and then just bringing that fold into the next line in the sequence. So I'm going to repeat this over here. So what I do is I take a line as a mountain, and I can do the same so for the next one. So these two are mountains right there. My light is sort of all around right now. The camera doesn't know what's what. So I can just take this. This is like the double mountain trick, only taking advantage that the mountains are parallel. Because if they weren't parallel, then I could use sort of the intersection point as my reference. And I usually do. It's very rare that we use mountain tricks that are partial, but you could do it. I mean, it's very interesting how the double mountain trick, you can pretty much bisect any angle, even if you don't have the origin points or like the point of contact of those two lines. So Ben Parker has been working actually on the system of notation on the hexagonal triangular grid. So this is actually what we're doing right now could come to play tomorrow during the talk. I mean, he might just go like getting like a map notation. I think it's going to be like a map thing, going like, all right, you go certain steps to the right, you go certain steps to the left, and you apply this move or you apply this other thing. And if you apply this thing, then you use this symbol. If you apply this thing, and you use that symbol. And if you use that symbol, that means that you can't do this thing on the other. So it's just a matter of establishing rules. So I've been thinking a lot about quasi-periodic patterns again, trying to wrap my head around the idea of quasi-periodicity. And it's a very interesting topic for me. I've been researching it for about maybe 3 years now, 3 or 4 years now, maybe even more, maybe like 5 years. And in those 5 years that I've been just looking for more articles on it, more books on it, just trying to wrap my head around the idea of crystallography as a science and just a study of crystals turned out to be paramount to all this. Because one might begin to wonder, studying all these tilings and all these patterns, one begins to wonder that famous phrase, what is this for? How is this useful? What does it mean? And I guess the answer to that is not just like, how do I turn this into money? It's more like, how do I turn this into reality? Like, where is this in reality? Is this just in my mind, or is this just something that's real? Where can I find this if it's real? And the answer to where you can find these tilings in reality is in crystals, or in the molecular order of all things. So it requires some higher dimensional order to appreciate some of these, and also it might require many expensive tools, to fully appreciate these things. The advantage that we have is that a lot of those expensive tools are paid for by institutions and universities or laboratories which need their findings and research to be published for other people to take advantage of it, or, you know, just as a matter of fact kind of thing. Some research is behind paywalls, some research is more confidential because crystallography, or like the study of crystals, is used to manufacture drugs. I'm talking like, you know, medical grade kind of stuff, because they run simulations on how different molecules could match, or they could, you know, tessellate. They're pretty much just like making tessellation software and just establishing each molecule as a piece, and then you just sort of mixing them together and see if they match, and then they do their tests, and if they match, then great, that they have just sort of synthesized a new component, and then, you know, a new drug, and therefore, you know, just this whole thing sets in motion. So quasi-periodicity came about when in the 80s, it helps me to talk about these things, I guess, but in the 80s there was this guy in Israel who was working in a laboratory. He was, for some reason, just studying these compounds of aluminium and magnesium. I forget the number. I think it was aluminium 18, magnesium 54. I don't know, something like that. I can't remember. But I don't even know what that means, though. I'm not a chemist. But he found that there was this tenfold pattern in the molecular arrangement. And that was weird because the laws, the mathematical laws that were used in the 80s for studying, you know, the tilings of things was actually prohibited patterns that had tenfold symmetry. It was prohibited for a crystal to show tenfold symmetry. And the reason why that is actually pretty interesting, and I recommend a little research into that, but it has to do with the way that, curiously enough, the bow tie shape in Islamic patterns pretty much showcases why that is, and that has to do with how a unit length is not always touching the adjacent unit length. So you won't always get like these sort of very crafted polygons. You will have like these weird polygons, which in Islamic geometry, they're called like the Sirish tiles. Yeah, that kind of tenfold, the bow tie, the irregular hexagon, I guess the other bow tie or whatever. So there's all these shapes in the tenfold family, which turn out to correspond to the way that molecular order might be arranged. So there's this article I uploaded to the Discord server. I think it's an electron microscopy, high resolution of that aluminium magnesium component. And if you look at that picture, it's a very high resolution electron from electron microscope. And if you look at it, you will see an Islamic pattern on it. Like you will, if you see Islamic patterns a lot and you look at that picture, it'll just pop out at you instantly. It will seem like it was like a screen, a lattice of an Islamic pattern. So you begin to wonder, if these, so there's two ways you can interpret that, right? You can interpret it as, oh my goodness, these guys were like ahead of their time. They were geniuses. They knew about the molecular order of things, whatever. Or I think this is the other way, and I think this is the correct one. Sort of space has certain phenomena, and if you are keen enough to look at them, they will show themselves. And they are like, it's almost as if God is sort of peeking through a window. If you have the right tools and the right disposition, you might just look back at God looking at you, kind of thing. So the theory regarding why we don't see that as much is found in Paul Steinhardt's book, The Second Kind of Impossible, The Quest for a New Type of Matter. It's a great book. It's a very interesting book. It's pretty much just like an adventure book, but it's how he sort of ended up traveling to Russia looking for this meteorite sample, because it turned out that there was nothing on this earth that had that tenfold symmetry, but there might be on sort of a subject or a sample, from something that's not from this earth could actually have that symmetry. And it turned out that there was this meteorite that this Italian man had in his collection of minerals that turned out to be a sample from this meteorite from this lake in Russia. And so he and his team had to go to that lake in Russia where there had been sort of across time several meteorite crashings and look for that sample. So almost done here with my pattern. Depending on how you approach this, you might get different results. No, I'm not kidding. I'm kidding there. The only thing that you might get different is if your rectangle is bigger or if you were more keen on doing the thirds division. We didn't look at the thirds division right now, but we've seen that on the hexagon. So maybe it's an interesting kind of homework assignment, sort of dividing these lines into thirds. But you will need an additional division there. So all these things, very interesting, very interesting. So I'm almost done here. And this is a pretty good grid expansion. With all this talk, I don't know if actually I'm going fast or slow. But yeah, quasi-periodicity and all these things, very interesting, very interesting. Now, as much as they are chaotic, so then the question begins, all right, so how do you define a quasi-periodic pattern? And the reason they're called quasi-periodic is because they show some order, but it's sort of a chaotic order. It's an order that is hidden, usually. But that also relates very nicely to the idea of Islamic patterns in that they obey sort of the way that you can put together the pieces almost. The chaotic order is a matter of creative endeavor. You get to choose what's next. Alrighty. So I have my grid on, so nice. So what's next is to find my circuit. So here's the way that this circuit's gonna work. You're gonna take out a pencil. And so we're gonna trace the circuit. Let me take out my pencil. Where's my pencil? Wait a minute. Okay, so this is how you choose. So, get to find any place on it, pretty much. So these are the ones I'm going to choose. You're going to choose a rhomb, pretty much. And then...
Could you wait for a second? Because I thought my grid was complete, but then I now noticed it. From this side, I've not folded it. And I was sitting just like that. I thought,
yeah, that's fine. Yeah, I can wait for you.
Just a second, just 2 more lines. 3 more rows. It will be accurate because I'm doing it very quickly right now. Yeah, I'm done.
All right, so this is the line that these are the circuit that you're gonna do. So you're gonna do sort of like 2 triangles in a rhomb, and then on the short side here it goes line, and then it gets a direction. So you're gonna have to choose if it goes to the right or if it goes to the left. I'm gonna go to my left, so I'm gonna use this line. So it's gonna be 3 units. So it's 1 unit here, 2 unit, and 3 unit. 1, 2, 3. Same thing on the top here. 1, 2, and 3. Goes up like that. So on the third one right here, it goes Well, it depends on how you look at it, really. But then here, this one also goes 3. So 1, 2, and 3. So it's 3 where it hits, 3 out, and this including the triangle goes 3 and 3. Now for these over here, depending on where you're going, so this one is sort of like, like a little hand that's like lifting. So this hand is sort of like raising its hand. So it's going to go this way. So you're going to go like this toward the left, so toward the lifted hand almost. Like that. And so with this rhomb, now you can sort of do the same thing again, where you can sort of draw your lines so you can get to sort of appreciate how that's happening there. So if this one's coming in there, then the next one's going to come in here. No, what? No, it's going to come in there. A little bit. I'm getting there. So for instance, over here, the lifted hand is sort of over here, then this coming down. So can you see sort of the circuit we're building?
Yes.
You can also appreciate it as though it were diagonal almost. Like these are related and these are related. So these are going to be sort of arranged so you can see on the same sort of line, just as much as we're going to see how these are being arranged in a line. So we're going to keep drawing in our pattern. So I find that it's easier for me to sort of imagine how the short line here, so the line that's coming in from there sort of goes 2 and then 1 into another. So this one's going to go, 2 and then into another here. If that makes sense. So it's going to be also like a top one. So it's going to be like this.
Yeah, I did it in the other direction. Like one is going like this and one is going like that. So
All right.
that is.
Yeah, that's perfect. As long as it works, perfect. Don't matter.
I don't know whether it was.
So once you have more, then you're going to see, for instance, like this one goes across, and I know that this rhomb is going to be here because you can see these rhombs are all on the same. So it's almost as if I'm going like rhomb, 1, 2, 3, rhomb, rhomb, 1, 2, 3, rhomb. And for these, well, we're not seeing them yet, but it's going to go here as well. It's going like rhomb, 1, 2, 3, rhomb. 1, 2, 3, rhomb. So I'm trying to sort of now look at it through that lens. And did a line too many? Yeah, this line shouldn't be there. So we all set up? Everybody got so far? At least sort of the idea of the sequence?
I didn't get it. Never mind, I'll finish it later.
This might seem a little trivial, and by that I mean that, it might seem, I don't know, maybe unnecessary in a way, but, it really helps to see where you're going. Well, it helps me. I don't know, what I really like about it is how well it coordinates. Yeah, it's almost as if the one that's not coordinating is me. Wait a minute. 2, 3, 1, 2, 3. All right, seems I'm done with the marking on it, so cool. All right, so this is now how it's gonna work. We're gonna look at each of these rhombs that we have set up here, and we're gonna squish them. So here's how that's gonna look. We're gonna squish them, we're gonna make sort of a rhombic shape on them. So we're gonna have to first establish all these lines that we have drawn in as though they were mountains. So it's almost like,
Is it possible to wait a minute? I just finished my pattern. Sorry.
oh no, you're fine, you're fine. Yeah, I'm gonna wait a little minute here. Okay. So next part involves us, we're gonna choose any rhomb. I recommend you get one in the center because it's gonna be easier to sort of appreciate. But what you wanna do is you want to sort of imagine all the lines we've drawn in as mountains. So I'm gonna draw in these as mountains, and this line as well as mountain, and then these two. And so what you're gonna sort of be quick to realize is that when you try to collapse it like so, in order for this to make sense, like structural sense, you're gonna need the line right after. You're gonna leave the line after to sort of fall on into. But it should look a little something like this. Once you can make it fall, it should look a little something like this. You get to have a little octahedron here. You can see that it's sort of like 4 triangles there. I know it's kind of cute actually. Like a little bulgy thing. So let me know when you got your little bulge. You can see that on the inside that it looks very cute. I like it. I like how it looks. It's a very interesting sort of circuit. But for this pattern, we actually, so, you know, if we were so inclined, we could, you know, theoretically, establish all of them. Sort of like, all right, so then we go for this guy, you know, like try to get all of them to pop. And we could do like one by one in a way. But because of the nature of the pattern we chose, there's going to be some overlaps. So it's going to be hard to do them all at the same time. You know, like this is pretty much just getting in the way of these. So that's why we're going to do one by one. So let me know when you have this shape established first.
Yeah, it is there, I guess.
Can you show it again?
Sure, sure. So I'm gonna pick another one just to sort of get a fresh one in. Okay, so I choose, you know, like that line that's going out after the rhomb, and so here as well, the line is going after the rhomb. Get a full line, and then I'm going to line up the rhomb, this one. And the line is going out the rhomb on the bottom here. And now what I need is to be able to sort of fall into, so again, this is the line I'm choosing, this mountain here, but I'm gonna need the one after it in order to twist it. You know what I mean? So because of the way that sort of also, the lines I'm choosing, the twist is sort of happening to, you know, in the direction of the happy hands. I'm calling everything happy just to put a smile on it, but really just like hands, you know, just in that direction of the hands. And so notice how, so this layer is sort of coming in down like so. So is this one. So there's a layer that it's sort of we're folding onto. Yeah. And it should be bulgy. It should be hard to sort of get it to be flat. Well, of course it's going to be hard because we got this very, very 3D looking thing here. And I insist that this looks kind of cute. Little hands on it.
Can you see my picture if I fold it correct or not?
Sure.
Oh, here.
Let me see. So once you have that, here's what's next. So you're going to take your little cute thing like that, and then you're going to sort of put your 4 fingers right there on it, and then you're going to sort of squish. You're going to do a little squash fold here. So just bring it all down. Sort of make sure that it's going towards toward that point right there.
Hmm. Interesting.
And so that squash will give us this very full motion rhombic twist. And now that it's flat, it'll be easier to interact with the rest of them. So we can leave that folded in and then just choose whichever one we want next. We can sort of make it happen sequentially. And so we can like choose this one that's next on the sequence here, for instance. And so I begin to sort of establish the same movement. Now here, this is an interesting little tidbit here. When I fold the next one in the sequence, we're gonna have automatically, you're gonna see this overlap happening. You see, this one is already falling in and this one sort of falls on top of it, and that's fine. So again, we establish that and then we go for the squash. So when you're doing the squash, just make sure that the line is actually just going towards the points. So we could actually fold those in another way, but you know, whatever. As long as we get the idea, I think that's good enough. Now, because of the way that we were dividing this thing, we're gonna get this thing underneath, see? It might be difficult actually to fold all of them at once. So what I mean by at once, I mean that to have them all be folded in flat and then also try to get them to work in this you know, circuit way. So what you could do, if you wanted to sort of save on energy and time, is you do one and you unfold it. So like you solve for a rhomb, you unfold the rhomb. That's totally valid, and you just take it one by one. It might be a lot more work, but it's cleaner. Because you won't have any overlaps, and therefore will save you will save on sort of like the messiness.
Excuse me, the adjacent rhomb will be in the same direction or in the opposite direction?
The what now?
The adjacent rhomb, like if we fold one, the other one will be in the same direction. Suppose one is clockwise, the other one will be anti-clockwise or the same direction.
You know, it's an interesting question because it really is sort of just of course it is a rotation, but I think that by a process of relationship, sort of we get to imagine them as being rotating. You know what I mean? But yeah, you can also picture that rhomb to be just one unit after, you know, this rhomb. So for instance, right here, this could be the next rhomb.
Mm-hmm.
What's interesting also is that we're not really adding any other folds. I mean, other than the rhomb shape, the circuit, the rest of the circuit is solid. All the other lines that we need to make this work are already there. We're really only adding the lines that draw in the rhombs. So, you know, by process of elimination, I know that my next rhomb is going to be right here. So I think there's a very beautiful circuit play happening here. And with how unusual it looks, it's also quite pleasing. I like things that look unusual and weird. And then they turn out to be, you know, very structurally sound.
I think two adjacent will be in opposite directions. Isn't it? So,
You might be right, Sashi. I think you might be right. So it should look, once you get more than, you know, 2, in this case I have 4, it should start to look a little something like this. And on the other side, you're gonna have this weave. So, you know, if you were so inclined also to want to save time, you can simply just add the rhombs and mountain folds. And that will also solve for it. No need to squash, just simply draw in with some mountain folds where you know the rhomb is going to be at. And save time. So I simply just select these 2 points that I know my line is going to go through, and I fold a mountain right there. And that is, again, the same thing. It will solve exactly for it. So there's many ways to look at this pattern also. I mean, you will get to appreciate how the brand that's within these twists, so this sort of like this strip, is what's going to get weaved on the other side. So no, this is what's sort of getting pushed into the one next to it. So this is getting pushed into the here, you know. So what I really like about this pattern is that there are many ways that you can look at it. Hey, Fatme.
Again.
So what I'm doing now is, instead of doing the squash, I'm simply just like, you know, taking the lesson into account and going like, all right, so I know how to draw in the rhombs. So I know where the rhombs are going to be at. So I can just draw in mountain folds where they're going to be, you know, preemptively. Where did I put my pencil? And so when I do these rhombs, I'm gonna sort of begin to see another new decoration happening here. And that's this shape. sort of like this weird octagon shape thing. But the way that it's sort of built also implies this. And so it's that strip, it's this brand that's there, that's the thing that's going to get weaved. So if I draw in the other one here, this is getting sort of pushed. This is getting pushed into this on the bottom of it, you know? So this is the illusion of the weave. This is what makes the weave work, and that it's all sort of branded on these. You can also appreciate how like this strip falls on this and this strip falls on here. So they're actually like side by side, you know, and there's still like two left over that we can appreciate. That's what we get to see on the other side as what's sort of underneath and on top. So again, very beautiful pattern. I'm going to continue to draw in these without the squash, even though the squash is a lot of fun and we get to see the cute little guys with the little shaky hands. Very Twin Peaks kind of looking thing. If you saw Twin Peaks, you know what I'm talking about. And if you didn't, well, it's just like the shape that comes in the season 2 weird double triangle shape that according to them is pretty profound and symbolic, but it's weird how much it looks like this. It's just like a Lynchian thing, you know, just like this unconscious coming forth of an idea. So again, just marking in my rhombs manually. Just finding these points, these lines that I'm going to draw it into. And this is where the drawing in of the pattern comes in handy, so you don't get lost into where, you know, your circuit is going to go into. So I'm going to try and activate this, see how that looks. So this is also why it takes me forever to do anything, because I always stop midway of a thing and go like, oh, let's see how this looks so far. It's like, just keep going. Why are you stopping? That's also a thing of the origami tessellations or twists or corrugations or whatever, that they require sort of a full expansion or a full, you know, pattern, I guess, for it to be significant. To collapse this is difficult in that there's a lot of overlap happening. At least especially if you're incomplete like I am. Like if your pattern is complete, it will be more harmonic in its collapse. But there. And what's cool about them being overlapped is that we get to choose what's on top of what. And so we can also make a little sequence on that. So I can see like, so I can say, you know, there's two types of rhombs, right? There's the ones that are going like sideways and the ones that are going up, you know, these are going. So I can say that, all right, so the ones that are going sideways, the one on the right is going to be on top, and the ones that are going up and down, then this one's going to be on top of this. So this one on top of this one on top of here. And I can do that little zigzag of what's, and then that sort of makes it be a little flatter because everything's just holding itself together almost, like an underneath on top, underneath on top. And so it also creates this very nice sort of shadow inside of these weaves. So that's pretty interesting as well. And so then the action fold that I did, that it reminded me of the action basket from before, is then to fold this sort of halfway like this, and then just sort of squash on in on it. But I think that's very superficial and not really necessary for the structural integrity of it, but it will create like these little island shapes on this side. So I think that's also interesting. But that's optional in a way. But you do have to do that. So how are you feeling? You guys want to keep this till we finish, or?
I should have listened to you, and I should have drawn those rhombs around the rhomb.
Yeah.
Now I'm having a hard time because I was enjoying that spread squash so much, so I didn't draw that.
It's hard to do the squash while the rest, so it's really hard to do the squash while the rest is folded in. So if I have this folded in and I wanted sort of like to do a squash on the fly, it will prove to be difficult. And it will also provoke like these little inaccuracies, I find. So I think it is better to fold in all the rhombs first, whether it be by individual squashing or, you know, anything, any way you want to do it. If you want to do them manually, whatever, just as long as you can put in these rhombs before you do the whole squash, I think that's better.
See, this is what I have got so far.
Oh, that's beautiful. Look at that. Oh, wow. It's so cool. I'm glad we didn't do it on a triangle because it really looks weird on the triangle. I mean, it's fine, but this is much better. Look, you get to see the full expansion of the pattern. And I hope it also provides perhaps some sort of insight into these sorts of weaves, like how they sort of work, maybe the internal mechanics of them, to maybe inspire you to try some yourself, like try and to break it down, you know, what are the general rules of this? And sort of like that's where the math comes into play. So I think that's also the advantage of drawing in the lines. Maybe your mind will go like, all right, I see what's happening. All right, so I need to just fold these rhomps. So it's pretty simple in that, you know, it's just these rhomps and these lines. And once you get the chain of it, once you get the idea of it, then it's just, you know, consequential. I'm almost done here, and I'm aware that this is taking more than it should, perhaps. How you guys doing? You got your weaves done?
Almost done.
Almost done. Okay, good.
Still there are few be done. One more, two more.
So I'm going to take it from the top. Apparently, you can also look at it through this lens of, you know, diagonal, unit, diagonal. So in here, for instance, I needed to put in a diagonal here because it didn't have it. So it's like that diagonal unit. It's out there, that diagonal. I mean, in a way, you know, same thing here. And this requires like the whole thing to come together almost at the same time. How you guys doing? You got it going on? Or are you having as much trouble as I am?
See,
Oh, beautiful. Look at that. That's very nice. Way to go, Sashi. Me, I'm almost done as well. I should be done just about now. Now, the second part of this, which is apparently something that we're going to have to sort of like maybe do in another class because we still have to go to the Islamic Pattern section of this, is to sort of make space on this side for it sort of get rid of all this overlap. So to clean it up a little bit. And that involves us separating where these are matching. So for instance, these two are crashing together. These are sort of coming in. So it would be a matter of sort of folding this back and then folding that one back and then tucking it in. And that way we would get rid of this overlap. But the downside to that approach is that it will create some sort of, it'll create some space within here. Like it'll be like a little bulgy thing. If we do a single sort of mistake or something that's done a little bit too much, it will, yeah, it's a little, yeah, anticlimactic, if you will. So I guess now it's just a matter of sort of arranging these so that, you know, like they all respect some sort of sequence. So like this is on top, and this is on top, and this one is the other way on top. And you can still make order, even though there's overlaps, you can still have order. And there we go. I don't know about this line, whether it's would be, this one would be folded in or down. I don't know. I would fold it out just so that I get to see the weave a little bit better. But all right, that was fun, wasn't it?
Yes.
So we're gonna put a pause on this for now. So it's interesting to see again, like how this rectangle became this rhombic shape though. So that's very interesting. The way it got reduced to this, very, very interesting. Now I guess the next point would be to sort of like wrap this around like so, almost like mark these lines as mountains, sort of like that, then have it wrap around itself. You know, maybe we could even tie it up in another way. Not necessarily like front to front, but actually get a little twist in on this. So yeah, very nice pattern. I really enjoy this one. Hope you liked it.
Yes.
Brand new.
Different.
Excuse me?
It's different, nice.
Yeah. So, okay, we're gonna move on to the next one. We're gonna leave this here for a bit.
It's,
So we're gonna put a pause in at least like how to make this be more like the islands that I showed you. I'm gonna put that for another class. But for now, we're gonna need a square, or at least the reference of a square. So what I do, and it'll produce, you know, very fairly accurate results. So what I'm gonna do is I'm gonna cut out a square first. It's not strictly necessary to cut out a square, but I think it's the easier way. So I'm getting out this rectangle, and then I'm not, so this fold that I have here, you know, it's not completely useful, and it might actually get in the way. So I'm trying not to fold at all in the middle here. But in order for this to be accurate, I need sort of like this to be actually spiky in a corner, And this whole line, like the whole line, entirety of it, has to be on the edge. If I can establish that, then it's just a matter of then traveling from this point in a flat line towards the other end. And where that hits, so if this line is flat and then I can at the same time have this line be flat, I will find where that's a square. So where that line, if it were folded in, I would find where that would hit. If I wanted to be sure, I can then take the other one. That's another way to do it. And then just fold it in like so. Sort of like the same process, but the point being that when I fold that it would have to hit on the point that I marked. So it's just a way of getting a square without having, you know, anything folded in there. And then what I do is I sort of take that point, I keep it folded a little bit, and then I just twist it, and then I just fold wherever. Doesn't really matter as long as I can get a fold. Once I have that fold, then it's just a matter of sort of pivoting so that the line is matching to it, but you know, trying to keep that point. So this is my way of getting a square without folding in the lines of the square. Sort of, you know. Now it's not strictly necessary you do it this way. You can fold the line if you want to. Just know that, you know, it's not going to be useful for our construction, and it might provoke you to think about other relationships that are not there. So yeah, but it's fine. I mean, it really is fine. Okay, so I've cut my square piece of paper here. I'm going to fold this in half. My camera's doing that thing again with the bulging lights. So I fold this in half. Now I need the √5 relationship. So with this folded in, I'm going to do sort of like the top corner to the bottom corner. So top corner to the bottom corner. Once you have that, now you fold this edge, which you have on the long, so if this is the triangle, you take this edge and you put it onto that line of the triangle. So this is like the double mounted technique, right? So you're bisecting this. Now you want to bisect over here as well. So this line we already partially have, but we only want until we get to the intersection. So we're bisecting these two angles right here. If we bisected this one on top, it would hit in the exact same point. But we're doing these two because they are the more obtuse, if you will. Even though these are all acute, but this is more open than this one. So it's easier to sort of see and appreciate. And also the extension is closer. This distance is a lot shorter than this distance from way over here. So also our lines are not getting too much in the way. So now on this intersection, on that point, we want to draw in a perpendicular line. So same intersection, just I'm marking it on both sides. Now, when I fold it, I want to make sure that the line is going through that point and it's perpendicular. Now, if it was perpendicular, that means that this bottom edge and this top edge, because this is a square and all lines are either perpendicular or parallel, these will match with themselves. So these two match with themselves. And the line goes through the point, and these two match with themselves. Falling on itself, falling on itself. And if you did it the opposite direction, so if these two folds that you do here are mountains, and then you do this fold in a valley, a way to quickly check if you're correct is to simply pop it. And because it's going right through the intersection, you should be able to sort of appreciate a little bit of that interaction. So that interaction would suggest that the line is going through the point. So all well and good. And now what we want to do is have the same line on the other half of the square. So in order to avoid all this construction that we did in order to get this line, what we do is we simply have this line folded, fold the middle line, right? So we have it like that, and we fold the middle line like so. And now we want to fold this side to the other side. You could fold it this way, but the overlap will create this little error. So what we do is we turn it over to where this side is bare, and then we fold that like so. And we don't really need this whole line. This is just sort of to make it easier for us. All we really need is where it's hitting the edge. This right here, like all we need is this point. We don't need the whole line. We don't really need the whole line. We just need the point where it hits the edge. That's all we need. Everything else, all this line is just aesthetic. We just really care about where it hits the edge and that the one next to it is sort of equally spaced. But that's all. This whole line, unnecessary. So now what we want to do is we want to imagine. So I'm going to take out my compass just to demonstrate what we're doing, sort of in another manner. But, you know, you don't need a compass for this at all. But it will help to sort of demonstrate what we're doing, what we're trying to do. Maybe I should get a little... I have this thing, this vinyl thing that I have here. So in order to not to keep damaging my table, which is pretty much damaged already. It's pretty damaged. That's fine. So my compass is not big enough. Yeah, simply not big enough. So yeah, scratch that. So we're not going to use the compass to demonstrate. But if it were big enough, it would pretty much what we're doing is establishing this distance and then just drawing in on where it hits the edge of the square. So we're taking from that point and then matching the other corner that I have here. Sort of like this point that I'm drawing in is the same as this one, you know. And so I'm just making sure that it lands on the edge of the square there, right there. So we haven't done a fivefold in a while, so this is also why we're doing this. Pretty much been doing Islamic patterns in the 8 and 6 family. We're still to get to the 5s, and we've folded, I think on the sessions, we haven't folded any 7s. And I think we damn well should, because with origami, we can actually fold an exact heptagon, an exact seven-sided polygon. Something that we cannot do with a compass and straight edge, no matter how accurate we are. So we should take advantage of it. So again, this distance is sort of where this is going towards. Like we're having this radius, or this be a radius, right? So a radius is the same in all directions, but we're trying to have it match where that hits there. Okay, so we do that on one side, and then we do the same thing, but on the other side. We could do it as a mirror trick, or we could simply repeat the process, where I now have this point be my anchor being what's sort of not moving. So I know that the fold has to be coming in from that point, and that the other one, this one, you can see even the point is going in toward the line there. That's hitting on the edge of the square. Now, if you followed me along, there's actually a YouTube video for this way of getting the pentagon. I call this the geometrical way. Yeah. So now we have this is the bottom side of an regular side pentagon. And what we do next is we fold a valley right between these two mountains to have it sort of collapse like so. So now we've tucked in that triangle for the pentagon. Everybody good up to here?
Yes.
All right, good, good, good.
Sorry, I just don't get when you fold the last fold. Yeah.
The last fold, do you mean the other line or do
Yes.
you mean
No, no,
the
no, no,
line?
no. How you can split this one, the two spots? Yes, you put it your hand. You put
This.
your hand. Yes, yes.
Okay, so the process, we're repeating it, but now on this one, pretty much. So the first line that we did involved us sort of taking, so let's say that this side is the anchor, right? Let's say that this is the unmove. This is sort of, if it were a compass, this is where the thing just gets anchored into the surface, right?
Yes.
Okay, and then we have, well, this distance. And so what we're trying to find is where this distance lands on the edge of the square. So it's kind of going like,
Huh?
so we take our paper, and what we want to do is have a fold originate from that anchor point, and then have the other point, which I've drawn in here with a pencil, on both sides, just to be able to see it on both sides. You can see there the point.
Oh yeah, I got it.
Then I fold it, and so what I'm making sure is that it's, again, originating the fold from that point for this little bit, and that the other one is falling, you can see it, on the edge of the square.
Mm-hmm.
So it's, maybe it might look like it's a
Yes,
little
I get it.
Yeah.
But just one question, is it the point in the middle? Is it at the same at the middle of the point or not? It's a little bit below at the center of the square.
No, the center of the square is here. So the center of the square is here.
Mm-hmm.
This is the center of the square. So
No,
right
no,
now,
that's the center from up the triangle. If you open the paper, you see the triangle in between. One is up and one is down, and it has an intersection. Yeah, in that point.
Yeah.
This point is not in the middle of the square, isn't it?
No,
Oh.
no, it's not. But that is the center of the pentagon.
Yes, yes. Oh,
Yes.
interesting. Okay.
So what happens is that all the odd-sided polygons, so the odd-sided polygons, you know, they have, the way I see them in a way is as though they had legs and head. So for instance, the triangle has like 2 legs and 1 head. And then the pentagon has 2 legs, 2 arms, and 1 head. And then the heptagon has 2 legs, 4 arms, and 1 head. And so it pretty much just happens to add by 2 how many arms it has. So the nonagon is going to have, like, you know, 2 legs, 6 arms, and 1 head. The thing is that if we establish the legs to be inside of a square and then have the hands sort of be where the square is sort of happening, if you get my drift, like have the arms sort of like be exactly touching at the edges of the square. Same thing here. Well, this one would be a little bit different, but no, actually no. Simply lift up from the legs. Actually, I think that, yeah. So what's going to happen is that it will never, the head of these odd-sided polygons is never going to hit the top of the square. Like, it will always have a little bit left off between the toppest points and the top of the square. If we do that like in an AutoCAD or in an Illustrator, and we do this experiment with the odd-sided polygons, this will always happen, where the head will not touch the ceiling. So yeah, as we up how many sides it has, it's going to get closer and closer to the top, but it will never reach until infinity. So once we reach infinity, then this will be landing to the square on the top, but it will be a circle because it will be infinity.
Thank you so much.
Oh yeah, no worries. So once we have these two, now we draw a valley between, and these get tucked. And so now what we do is we do what I call the hinge move. The hinge involves us having this little thing actually be like a little operative thing. So we can see that this is getting tucked, but we have some ability to lift. And so we keep this side flat where my left hand is, keep it flat, and my right is going to lift it. And so what I want to do is the fold needs to be where this line is. So this line is the hinge. This is the operator. This is the move. This is the part where it's moving. So what I want to do is have the fold be exactly where this fold is in order for this to work like so. And if I did it correctly, that's going to hit on the edge of the square, or the edge of this shape right here, which is a square, but it's half of it. So that will hit there. I turn the paper over, repeat on the other side. You can see that this line goes straight, point hits on the edge of the square, and I fold back. And now I have what I call the fox shape. It has little ears, little fox face, and I do the winter fox move where it's just like, you know how those foxes in the snow, when they hunt, they just lift in the air and then their face gets stuck in the sand, in the snow, and that's where they catch their prey. So we do that, we put the face onto our surface here. And what we want to do is we want to appreciate how we have these folds already in. So we're going to fold one of them, and then we're going to sort of just get the other one by a process of consequence. Just very naturally, if we fold one, then this is going to get pulled and it'll fall exactly on this edge. And then we can do a little hinge move here just to have it be, available to us. If we did this correctly, it should match with no problem. Now, in my experience, this is a part where, we get to see a little bit of our mistake, but it's fine. This is a point of correction, and then we simply can get that last fold in. Now, the reason why I prefer this method to others of getting pentagons is because this is geometrically exact. And I mean that, well, if we did exactly what we wanted to do, and that is if we follow the instructions I told you, like to the letter, if we could be like, exactly precise, we would get an exactly precise pentagon. So that's why I prefer it to the usual origami way of getting a pentagon, because that one actually has some degree of mistake and it's sort of negligible, but because we're sort of constructing, we take care about the precision or the intention of what we're doing, it's better to do it this way. So you should be able to appreciate this sort of like now the fox face has everything sort of right cut.
Interrupt.
Yeah?
Can I interrupt for a second? See, during that World Origami Marathon, Sarapapa, what's her name? She suggested correction in that origami way of making a pentagon. She suggested a correction to make it accurate.
Oh, nice.
Yeah.
I wonder. I'm going to have to look at the videos. That's interesting. Yeah, any way that I can get, like, there's always some workaround. So I'm curious as to, yeah, it's probably accurate. There's always somebody coming up with some new solutions to these things. So another way to make sure that everything's correct is that if you fold this extra one, so there's 5 of them, and you have here, so it's going to be like 1, 2, and 1, 2, and then this extra tail one. And if you go the tail to the right and it matches, and then you take the tail to the left and it matches, then because both of them match to this, then they have to be equal. right? If one thing is equal to a thing that is equal to the other, then the two have to be equal. So this is equal to this, and this is equal to this, then these two are equal. It's a nice little relationship of logic there. So because of the pattern we're going to do is in the decagon, we're going to have to bisect these by a process. Well, we do this in origami all the time with the square. Now I'm going to do it on the pentagon. So we're going to take each of these, so all 5 of these we have here. I'm going to put one by one. We're going to take down what I call the spine. So it's this line that's in between, and we're going to just set it down and have it fall on the middle fold, like so. So we're sort of like bisecting these. So all of them get that same treatment. Now what I'd like to do for these is to make sure that when I fold them, that I'm sort of trying to keep a balance with all the rest of them. So I'm always trying to keep 2 on each side. So it's like 1, 2, and then well, it's going to be 3 here because this one is already divided. So these 2 count as 1. So same thing. So we go spinning around. And I think I'm missing one more. Yep, one more. So now, because on the last one, there's going to be 8 total. So it's going to be 4 on one side and then 4 on the other. And then when I fold that last one, then it's going to add 1 to each side. So now it's going to be 5 on one side and 5 on the other side. Now we're at an even number. And so now we have this, sort of like these kite shapes. So what we want to do next is, keep a balance. 1, 2, 3, 4, and 5 on my right, and 1, 2, 3, 4, and 5 on my left. And there's going to be a perpendicular line right there. There's only one of them. Like all the rest of them don't look like that. So if we had an X-Acto knife, this is the line we want to cut right there. That's where it's perpendicular, and all of them are going to be perpendicular. So that will give us a regular decagon right here. If you don't have this for whatever reason, you might have to pop it back. Now, the reason why we don't pop it back is because what we want to do is use this triangle here. This is the biggest triangle, which has this line perpendicular. Because if we go around, I mean, this is like the smaller one, really. Because we can find a bigger one, probably, well, not this one, but probably here, probably here. Definitely over here, we got a huge one. So this is way bigger than this one. What we want to do is we want to sort of try and get around this one. So I'm gonna imagine. I'm just gonna suppose that you don't have an X-Acto knife. just imagine that you don't have an X-Acto knife, but you're at this step, just imagining. So how could you, now the question is, how do you find the decagon without having an X-Acto knife? Well, the advantage is that we have our radial lines. So we know that the line we're looking for has to be perpendicular, and we have a point of origin. So if this is where it's at, then the next one's going to be from this point and then a perpendicular. So what we can do is we have a line that goes right between. I'm going to try not to move it around too much. So we have, so I'm just going to draw in this line just for right now. Now this line I'm drawing in is the apothem line. So this is what I'm looking for almost. So I'm looking for a line that's from that point and is perpendicular to this one. So the thing about perpendiculars was that they fall onto themselves. So all I need to make sure is that my fold is coming in from that point and that this line in the middle of this triangle falls on itself. And you're actually going to see some nice relationships happening here. Isn't that nice? It's going to hit just exactly there. Should hit exactly there. Maybe a little bit off, but you know. I think that it's more important to respect the perpendicular than it is to respect like any possible connection there. So now you have another point where your perpendicular is going to spawn from, right? So this one is solved for. Now we have where it's going to come in next. So it's going to go through that point and perpendicular to this one. Now we could do a mirror trick and just bounce it off, or we could just take that point into account and just make sure that this line is matching to itself. Again, we get to have a nice little intersection here. That point is sitting right there. So you can even see how these sort of ending on exactly on the square, and this one is matching all the way up to here. Now we have the other point. And we have now the next one that needs to be perpendicular. So on that point, perpendicular. You know, it might just go like a little bit off. Like I'm talking like millimeters, like not touching the edge. It might be that it's just like super, just a little bit, almost, but not really there. You know, happens all the time. New point, perpendicular. Now this one is of the pentagon. So this one for a fact, actually no, I might be wrong here, because I know that this one for a fact will fall on this line. So this one for a fact is going to fall on the line, right on the line. So I'm going to do the same thing.
Sorry.
No, go ahead.
No, I was saying you were right about the name of that book. It is origami tessellation, but then there's one more line, or inscribing.
Yeah. Do you have it with you?
I had it like from our library. I did some tessellations from that book.
Nice.
Long time back.
There's one called like a rhombic, which is very similar to the one we just did, but does not have overlap. So the circuit is a little bit more open. But that was like after the fact. So I did this one, and I was like, wait a minute, like I'm sure I've seen like this. I'm sure I've seen something like this, but no, not like this.
It's very similar, but I think it's not the same because some waves, if you
So, you know, there is this relationship, so it seems, with the square and the decagon, as we can appreciate by the fact that it's all like having these lines match and whatnot. And then finally, these two. So, you know, if you wanted to, you could like tuck these behind like so. And the idea being that, well, now we have all the lines that we need, but we can also sort of focus on the triangle that we wanted to, and then just sort of like tuck everything in around it. Now you can appreciate how we folded everything on the line. Looks almost like an elephant. So now all these lines we need to cut away. We only want the decagon. So as far as I'm concerned, so far, this is the biggest decagon that I've been able to construct, but there's probably a better way. There's always a better way. But you know, so far, from what I've been able to do, this is the bigger one. So now I'm gonna fold all these lines of the ring that we folded in on both ways. So both mountain and valley. And what's nice is that it's a single ribbon. So it should be a same cut. So one cut should give me all of them. So I'm just going to fold these in order to weaken the fold, or alternatively, you could just lick the folds on the part where you wanted to cut it. So that will also weaken by saliva the unions. So I'm going to begin cutting one. So I get to that point and then I bounce, hit the edge and bounce. Hit the edge, bounce. When that happens, when I cut like that, I don't mind. Like I keep going, and then, you know, I'll come back to it and take that away. It's fine. As long as you don't go within your decagon when cutting, that's fine. It's fine if you have a little extra. You don't want to have deficiencies. It's easier to compensate for extra than it is to compensate for something that's not there anymore. Because we can always get rid of things, we can't always just add things. We can't put more paper where there's no more. One of those things. We can always take away, but we can't always give. what I'm doing now is I'm going to sort of find all those excesses and cut them. Sort of like a very fine squeeze and like, you know, tearing away with my nails. Now I prefer 100% to use my hands for cutting, whether that be a square, whatever, because the thing is, when you put tools into the mix, you're sort of using the folds as a guide or a name. Whereas when you cut the folds manually, like we're doing right now, it's not that we're using the fold as a guide, it's that we're cutting the fold. You know what I mean? Like it's different. So the fold being like the cornerstone of our design. There is an advantage, disadvantage. We can use knives. I'm not against anything. It's just a matter of, you know, depending on what you want to do. Let's see. I don't know where I left my eraser, but this coffee is going through me, so I'm just gonna go take a quick break. Just a 2-minute break, and I'll be right back. Alrighty. So we're back again. So first step is for me to get into position. Get this out of the way. Good. All right. So we have our decagon. Now what we want to do is fold a 10-4 at the vertices. So we're going to have the vertices. They're going to be 10 of them. And then what we're going to do is we're going to count the vertices. We're going to start with a 0. So it's going to be 0, 1, 2, 3, and 4. So what I like to do for these sorts of folds is I like to take away everything that's between those 2 points that I'm looking for. So right here, I'm looking for these, right? 0, 1, 2, 3, and 4. So I find where these are mountains and I take those away like so. And then what I can do is I can sort of balance it out and do this shape. Everybody got this shape so far? As you can see, I'm sort of tucking away 2 of these triangles. So it's like, you know, 2 opposite tenths. I'm taking those away. The advantage to this is that when I do a fold, I'm going to use the corners as my reference. So you can see how I'm hitting the corner. And then I can do also the other side of it, just by matching. Now, of course, we can always unfold and refold, and we're going to see some very nice relationships here. You're going to see how this line is falling on that line. Can you see how these 2 rated lines match? You see that on yours?
No, mine is not falling. Maybe mine is a little off. Maybe.
Yeah, mine is also sometimes a little bit off, but I find that, you know, usually, so for instance, I'm on here, I'm also sort of, you know, missing a little bit. So what we want more than those lines to match is for the line to go from the vertex to the other vertex that needs to go. So, you know, I showed you one way of doing it. The other way was to sort of look for those references. And also what's cool is that one will always give us the other. At least that's the way of the pentagon and the decagram. See, what I mean by that is notice how there's this intersection right here. And that point will fall on that one. Now, why? Well, because this 10-4 is actually 2 5-2s. So on the theory of stars, so, you know, we write 10/4. And so then we look for common factors. So 4 and 10 have a common factor of 2. And so we divide 4 by 2 and 10 by 2. So it'll be 2 and 5 and yeah, So that, and the number, the factor that they have in common, we take that outside of the bracket. So we have 2 5 2s. So that's 2 pentagrams. And the pentagram has that property of the corner matching to the point on it. That's just a thing that the pentagram does. Now here I'm sort of looking for, so the first step we did, where we did 2 sort of opposite ones, give 1 line of each of the 2 pentagrams. So the pentagram will always be self-generating. That is, the pentagram will solve for itself. So each of these lines is going to be one of the guides for each of them. So when you complete it, you're going to have 1 pentagram, and then you're going to have to do another. Because this star is not a unicursal star. It's a compound. It's made up of 2 separate polygonal stars. Star polygons, rather. So it should be looking like this. Now the points I'm circling are the points that we were sort of landing on. And what I mean by that is, look at that. Look at how it lands on those points. Even by itself, like, this is very beautiful, you know. And if you wanted to, you could even bring this to life as it is. It's just a matter of sort of fixing for certain things, but it's pretty much all there. Okay, we ready so far? How are we doing?
No, not yet.
Okay, good. Pause the video a little bit. Yeah, so put a point at the bottom of the petal of the 10-4 star. And then you're going to draw in a 10-3 star on those points. So same thing where we did the 0 and counting to 4. Now on these points, we're going to do a star, but we're going to count to 3. There's going to be like 0, 1, 2, 3. And that's the fold we're going to do. Yeah? So a 10-3 inside of the 10-4 on the bottom of the petal.
Belly fold.
Yeah, I'm doing every of these lines. I'm doing this a valley, and these are pattern lines. So yeah, try and like actually aim for the intersection.
Then these points should be on the other side. It will be easier for reference.
Yeah, it would be easier if you actually draw the points in on both sides or on the other side, so you can see more clearly. But yeah, so a 10-3 inside of the 10-4. That's what's happening. And so this is actually unicursal. So the 10-3, the reason why it's unicursal mathematically is because 10 and 3 have no common factors. So it will simply go around 10 times without touching anything. But if there were a common factor, then it would close.
You have to fold all the way or just
Yeah,
till
all
that?
the stars, all the complete 10-3.
No. I mean, we have to make a crease all the way from
Oh yes, all the way.
this side to that side, or just to the points.
No, all the way.
All the way.
Yeah, it actually extends to the rest of the pattern. So yeah, at the end of the paper, there's some pattern lines on this. Yeah, it's a very interesting design. And it just fits in really nicely with the rest of the origami theory we've been seeing, at least with the nested stars idea and all this. So because these nested stars, also you could sort of take advantage of the relationship they have in this manner. Play around with the mountains and valleys of the thing. So these nested stars have a lot of potential, even in the origami sense, for these kinds of. And I love how these look, by the way. These sorts of looking things are some of my favorite things in the origami, and folding Islamic patterns. So we're doing a 10-3 at the bottom of the petal. So I'm just making sure that all my lines actually are going through those points, which are the bottom of the petals. Okay. So how we doing? We doing all right?
Yep.
Good. Okay, so here's the next thing.
Next thing, just a minute.
Uh-huh.
Yeah, I think done. I think I'm done. Yep.
Yeah. Okay, so here's the thing. We're going to do a fold, but only on 5 of these. We're going to do a fold where we're going to do one yes and one no. Let me just fix this up because I think I might be a little bit amiss here. Okay, so we're going to do a fold every 2 that's going to go through this intersection here. You guys see that intersection? On where this sort of line just goes across. You see that? So on that very point, we're going to do a fold on there.
Again, we should mark it on the other side.
Yeah, it is useful. Okay, so the thing is, the shape we're looking for, well, we have this cross. I don't know if you guys can see that cross I did. Yeah. So what we're looking for now is where this is coming down, and we're going to have to draw in a pentagon.
Just one question.
Yes.
You folded this bottom thing up, and then you unfolded this and then folded the other one?
No, the thing is, like, this is going to go every 2, so we only do it every 2. So not in this one, but the next one. So not in this one, but the next one. So every 2. So 1, not yes, no, yes. But what I'm seeing.
How do we, okay, there's one triangle. Okay, so then we leave this. Okay. Yeah, understood, I guess.
So what we're really looking for is just like where this is a pentagon. And it really isn't hitting on the intersection, but rather like a little bit on top of it. Now, what's weird to me right now is that this fold should actually land on it, but it's clearly not. So is this diagram mistaken? Can't be. Although this is looking much better though. So now the fold I'm doing is almost like I'm putting the edge to match to this line, to the 10-3 that we did inside. Can you see that, how I'm folding this and then landing on there? And then I'm going to use that line as my reference for it. So it was to fold the edge of the decagon to match on the 10-3. That will give us the bottom of the pentagon. So what I did is I used this fold, this edge of the fold, to go to the other side like this. All right, so that's how I match it. And then the pattern, sort of, I'm going to draw in this triangle here. So the pattern has two triangles, two decagon triangles that we're trying to solve for. So this is the first one. This one. So this line goes and it hits on that point. So bop, bop, hits on the line of the triangle. This pentagon comes in right on it. And now this next one will come in and copy. Well, actually, it will come in and hit here. So it's kind of like going there, and it's going to go across like so. Yeah. And it's going to be perpendicular to this line over here. So it's pretty much like the extension of this. So we could pretty much just repeat this 10-3 fold on the other one. So I thought that it was only going to be on one, but no, it's just the extension of it. So that one gets the treatment as well. Now, the reason why I'm fixing this is because apparently like I must have missed the first pentagon because the one next to it looks kind of stubby. So again, main objective, getting this pentagon and the pentagon right next to it. Although not really. So this one actually is not a pentagon. Well, it doesn't get marked as a pentagon, but this one will go across. More like this. Now what's strange to me, and really is strange because I'm not getting like the diagram is suggesting, is that it should match to the 10-3 star. So the 10-3 extension should have the center of the shape there. So it's almost as if then it's going to sort of bounce back out like so. But then it's more about this almost. I don't know how you guys doing for this. So yeah, pretty much we're doing this on all of them, pretty much just like this, matching to the 10-3 and then going up on that line. So weird that only for that one is the one I'm having problems with. The one I chose just had to be the one that was like a little off.
I've got mine also. I mean, one is off, very off.
So I'm not sure if it's more to do with the construction of the decagon. I don't think so. I think my case is just that I may have missed some of the 10-3 points. I think those might have been a little skewed. And so when you hit this line here, which is the one we folded upward, so it's almost like the line that describes a pentagon, it's going to do a bounce. Then we have to get the same line to come down on it. So we might benefit from doing the mirror trick on this one. Let me just now see what this is. So it is hitting some points, but mostly just on there.
It's different on all sides. There is some problem. I mean,
Yeah, me too. You know, like I think I may have missed the 10-3. And this bottle's looking very skinny. So yeah, something is definitely off on mine. I don't know. I think we might have to redo this one for later because I'm not really comfortable with the way this is coming together. It's so messy. How do you feel?
so I think so. There is some problem.
Yeah,
Because some lines are falling on the pentagon and some are not.
Yeah, for me too. I think it's really just a matter of my construction, but that miss, it really is provoking some things that I just do not agree with. I mean, it should, when these lines come down like so, like for the bottle lines, like these lines, these should be regular pentagons. like this one. So these three should be regular pentagons. Now, they're not. They clearly are not. Like, this is clearly not sort of where it needs to be. So something is just off. So yeah, I have to apologize, and like maybe we're gonna have to omit this from the recording. And we're gonna have to come back to it on next session because yeah.
It would be better.
Yeah. How you doing, Fight Me?
But we did one tessellation, which is really difficult actually, and you made it very simple.
Oh, so yeah, thanks. Yeah, that was very fun. Now this one, I can't wrap my head around why it's so wrong. Like, it's weird. I'm gonna have to go over it again. So weird. Yeah, we're gonna do a simple rosette next time. But yeah, 3 hours, we're gonna have to like cap it. Man.
Are you saying something?
Oh yeah, no, I mean just looking at the diagram, just wondering what could have gone better, how we could have solved for it. I don't know.
Never mind. Next time.
Yeah.
Okay.
Yeah, well, sorry for this whole like hurdle. At least we learned how to do the decagon. So there's that.
It's okay. It's okay.
Yeah, next time. How you doing, Fatmi? Hey, you?
Actually, I missed some part, and I'm just looking and I'm just thinking. Interesting pattern.